Question number 1 asks us to evaluate this function right here, which is f of x equals negative 2 times 3 to the power of x, and graph the function. So we're going to plug in these values over here into the calculator and see if we can spot the pattern, then we'll put them on the graph over to the right. All right, our first value right here we're going to start with is 0. I like to see that in the calculator and then spot a pattern from there. So we're going to plug in f of 0 equals negative 2 times 3 to the power of 0. Now in class we learned that anything to the power of 0 is 1, so that ends up being negative 2 times 1, or just negative 2, which we also learned that this right here on the left side is our y-intercept. So at 0 the y value is negative 2, so we'll plug that in there. The next one that we're going to plug in right here is 1. So we'll do f of 1 this time. F of 1 equals negative 2 times 3 to the power of 1. 3 to the power of 1 is 3. So we're going to end up doing 3 times negative 2. 3 times negative 2 is negative 6. So here we have negative 6. And we can see that our pattern is multiplying by 3, which from class we talked about the base right there is what shows our pattern. So from there, I'm just going to use that fact and calculate the next one. If I multiply negative 6 by 3, that gives me negative 18. And then going the other way with our negative exponents right there, that negative 1, if we plug this into a calculator, f of negative 1 equals negative 2 times 3 to the power of negative 1. That ends up getting us negative 2/3 because that 3 to the negative 1 ends up going in the denominator. So we get negative 2/3. Some of my students prefer fractions or prefer decimals instead of fractions. So if you want to write that in decimal form, you end up with negative 0.6 repeated forever. So we can round that to negative 0.67 if you wish to have it in decimal form. And we can see that our pattern again holds. Instead of multiplying by 3, we're going back the other direction, so we're going to end up dividing by 3 on that. If I do that one more time to get to the next step, we end up with negative 2/9, or if you prefer it in decimal form, that would be negative 0.2 repeated forever. All right, now when we put these on the graph over to the right, I'm going to start here with our y-intercept at 0, negative 2. That would be right there. At the next one, 1, negative 6, that would be, let's see, negative 3, 4, 5, 6. So 1, negative 6 would be about right there. And then 2, negative 18, that's going to put us down off the board, but we can see that we're down in that area down there. It's getting steeper as we go along. Going back the other direction, we have negative 1 and negative 2/3, or negative 0.67. So that would be just a little bit above the negative 1, in between 0 and negative 1. On our next step, we have negative 2 and negative 2/9, so that's going to be closer to the x-axis right there, and we can see that our graph is leveling out. We've got our asymptote over on the left side, so we're getting closer and closer and closer to 0. Now this right here, a little bit off. Let's fix that. It should get closer and closer to 0. I've accidentally drawn it so it ends up a little bit low. So let me clean that up, see if I can do that a little bit better here. All right, For question number 2, it gives us a table of values, but does not give us an equation. Our task is to write the equation for this. So we are going to use that table of values to find the pattern. In this case, we are multiplying by 6 for each of these steps. So that tells us that this is an exponential function. That means we can use y equals a times b to the power of x. In class we learned that a was our y-intercept and b was our multiple. And our multiple is right here of 6. We can just go ahead and put that in. That would be 6 to the power of x. We need to find our y-intercept, and we do not have it. You'll notice that we do not have anywhere that has an x value of 0, so we need to use our pattern to go back a couple of steps and find that. So if we reverse our pattern twice, we'll go to step 1, step 0, we would find our y-intercept. We're going to do that by dividing by 6. If we divide 52 by 6, it'll get us 52/6. That can be simplified to 26/3. If you wish, you could write it in decimal form. That would be 8.6 repeated. I prefer the fraction form so that we don't have to round anything. Going back one more step, that would give us an x value of 52/36, and that goes along with this x value of 0. Let me just move that up there. Now that simplifies to 13/9, or 1.4 repeated if you wish to have it in decimal form. So I'm going to keep that in fraction form. We're going to use 13/9 as our y-intercept, and that finishes out our equation. So we have y equals 13/9 times 6 to the power of x. On the next equation, we can see that our y-intercept this time is in the middle, so we're going to pay attention to that and make sure we get the correct value. The pattern on this one is to divide by 7. Divide by 7. So since we have all the information, we can just go ahead and write our equation. Y equals a times b to the x. Again, a is our y-intercept, which we just saw was 50, so I'm going to put that in there. Dividing by 7 is our pattern, but I'm not going to write it using division. I'm going to change that, so we are multiplying by 1/7, so it fits our format a little bit better. So we're going to put 1/7 as our constant multiple to the power of x. That finishes up our equation on this one. We end up with y equals 50 times 1/7 to the power of x, and that's all there is for that one. On our next example, we've got a story behind it, and so we're going to use our exponential functions to be able to answer a question here. First, we need to come up with our equation. So we've got to find our y-intercept, or our starting value, and our constant multiple. Again, this fits y equals a times b to the x. So a is our starting value. We can see that we have a starting value right there of $2,680. So we're going to put in that 2,680. And we're going to find our constant multiple by using this percent of interest. Now we are compounding annually, which means we're growing. This is exponential growth. So we need to stop for a second and think, what would our multiple be? Well, 100% represents our starting percent, and we're growing or adding 1.6% to that. So that would give us a total when we're done of 101.6%. We need to change that to its decimal form. So dividing by 100 to get that into decimal form moves this decimal over twice. That would get us a decimal form of 1.016. And that is what we're going to use for our multiple. So it would be 1.016 to the power of x. All right, so that gives us our equation. Y equals 2,680 times 1.016 to the power of x. Alrighty. Give myself some space here because we need to calculate the value of our account at 10 years down the road. So that's our question right here. That means we need to plug in a value of 10 for our exponent because we're measuring it in years. So that would be y equals 2,680 times 1.016 to the power of 10. When we plug that into a calculator, we end up with a total of 3,141.028, and that decimal keeps going. Since this is money, we're going to round to 2 decimal places right here to give us our cents. So that would be $3,141.03 for our final answer there. Next question is about Colorado's population. We can read here, it says Colorado's population grew 1% from July 2015 to July 2016. And it asks us to find the population after 20 years. Well, since this is a growth question, again, we're going to use what we did before, y equals a times b to the x, where we have our starting value and our constant multiple. So our starting value is given here. It says it's 5.4 million people when we have that measurement, and then we want to know what it's going to be in 20 years if this exact same trend continues of growing by 1%. So considering that 5.4 million to be our starting value, we end up with a 5.4 here for A. And then our constant multiple, we've got to do what we did before. So that 100% we start with, plus the growth of 1%, which we saw from here, gives us 101% from year to year. Changing that to decimal form, we end up moving that decimal over twice, and this is 1.01. So our constant multiple will be 1.01. So we'll put that in here, 1.01 to the power of x, and that is our equation. We have y equals 5.4 times 1.01 to the power of x. All right, now that our equation is set up, we can use that to calculate what the population is going to be in 20 years. So plugging in 20 into our exponent, we get y equals 5.4 times 1.01 to the power of 20. Again, plugging that into our calculator, we're going to see that that gives us a total of 6.6 with lots of other decimals behind that. But we're asked to round to the nearest 1/10 of a million, so I'm going to leave it right there at 6.6. That would be 6.6 million people. Make sure that you have those labels right there. So when you are done, we know what we're talking about. And our last question asks us to calculate the value of a new car that we purchased after a certain number of years. So we can see that we bought a new car for $36,000 here in 2016. And the depreciation rate on the average car is 12% per year. So we need to know depreciation. That just means it decreases. So this is an exponential decay question, because each year we're losing 12% of the value. So let's go ahead and calculate that constant multiple. Start at the 100%. This time we're going down by 12%. Since we're going down by 12%, that puts us a total of 88% of what we were the year before for each year that passes. Changing that into decimal form, we move this decimal over twice. That gets us 0.88. It's going to be our constant multiple. So let's go ahead and build out the rest of our equation. That's y equals a times b to the x again. Our starting value we saw up at the top was $36,000. That was the original purchase price of the car. So $36,000. Our multiple is going to be that 0.88 that we just got. So 0.88. And that's going to be to the power of x. So our equation is y equals 36,000 times 0.88 to the power of x. And we can see that's decay because our multiple is less than 1. We need to use that equation to calculate the value of our car after 6 years. That's what this next question asks us to calculate. So here we plug in y equals 36,000 times 0.88, and the value that we're going to plug in is that 6. When we get done calculating that, we see that it gives us 16,719, and there are lots of decimals after that, of course. So I'm just going to round this to the nearest dollar, because if we were on a car sales lot, they would do that. So we're going to put that total in there, $16,719 for our total, the value of our car after 6 years. Thank you for watching, and good luck.